All right, parabola notes, example 4. Okay, so it asks us to graph this thing, okay, and identify the vertex, focus, and directrix. So what I've done here is I've mapped out all the steps that you need to do. Now, just because there's no blanks to fill in, don't ignore this. This is exactly how you do this, okay? So it's mapped out nicely, tells you exactly what to do step by step by step. So when you're doing your homework, have this out in case you have to look at it. You do the same exact way, okay? So you shouldn't look at it and say, I don't know how to do this. Start with step 1. All right, so let's go through this, make sure everybody understands. All right, so one is we know that this is a parabola because one of the variables is squared, the other isn't. Okay, so we want to put it in standard form. So this is what we want it to look like. Now remember that there's really two standard forms, right? There's two things could happen, either x is squared or y squared. But we see in this problem that y is squared. Right? So that's how we know that we put y minus k squared instead of x minus h squared. Okay, so that's how we know that. So we need to know h, k, and p. Okay? So the first thing, we get this to look like this. So we're going to have to complete the square. Okay, so here's how we do that. Now we're on step number 2. Keep the y squared term in the y term, y squared term in the y. In other words, the y stuff. Keep the y stuff on the left, get everything else to the right. And of course, to move everything else to the right, we're going to add 8x and add 31. So now we're right here, okay? Now, it's probably wise to leave a space right there as you're writing this out because you know you are going to complete the square. So then you just got to figure out what goes right here. All right. And then, of course, whatever you add on one side, you have to add on the other side. Okay, so now we're in step 3. Now we're going to complete the square. Remember, anything added to the left side of the equation must also be added to the right side. And, of course, here's how we get this 9 right there, by the way. Here's we take this 6 divided by 2 and square it, right? So you add a 9 there, add a 9 there, and, of course, that 3 plus 9, I meant 31 plus 9 is 40. And that's how we got that 40 right there, okay? And so now we're almost in standard form. So we're still in step 3 here, okay? So then we write this as something squared. And of course, that's y plus 3 squared, okay? But we also had to do something over here too. We had to take this 8 out, okay? Because that's the 4p. So take a look right there. So we needed to know that. So we needed to factor that out of x minus h. So we could see exactly what x minus h is and what 4p is. And so that's why this is x plus 5 there, okay? And so look over those again, and now we have it in standard form. Well, now it's like what we did before. Now it's like what we did before. The vertex is hk. Remember, the h is with the x. And this is x minus h, so that's -5, -3. Now 4p is 8. Remember, that's 4p, so 4p equals 8. We divide a 4 on both sides, and we get that p is 2. And now we're going to use the graph to figure out the rest. But the parabola opens blank, either up, down, left, or right, right? So y is squared, p is positive. Remember, when y is squared, it either opens right or left. P is positive, so it opens to the right. Right. Okay? And the focus. Remember, now P is not the focus, but P helps us find the focus. So what I'm going to do is I'm going to go to the graph now. Okay, so the vertex is -5, -3. -5, -3 is right there. I'll put a V so I remember that that's the vertex. Okay? Now remember that the parabola opens to the right. Okay, we remember that the parabola is opening to the right. That means that the vertex is going to go right here. Because it's opening to the right, I go to the right p units, or the absolute value of p, really. P units to get the focus. And I also go p units to the left in this case to find the line that we call the directrix. And this is going to be a vertical line, so x equals something, right? All right, so we say that p is 2. So here's the vertex. So we're going to go 2 units to the right to find the focus, because remember, the focus is always inside the parabola, okay? Focus is, that point is -3, -3, -3, -3, -3. There we go. Okay, so there's the focus. All right, so now we need the directrix, so we're going to go 2 units in the other direction. We'll pretend that looks straight. Okay, so there's our line. It's our vertical line. We knew where it was because we go 2 units to the left there. Okay, all right, so there's our directrix, and it's a vertical line. It crosses the x-axis at x equals -7, so x equals -7. All right, so for the directrix, make sure you don't put it as a point. Make sure you put it as an equation of a line. All right, so now we're going to find 2 easy points. Okay, so the 2 easy points, here's how we do it. We have the focus right here, and remember all the points on the parabola are equidistant from, same distance away from, the focus and the directrix. So I look here and I see that the focus and the directrix are 4 units apart. So I go 1, 2, 3, 4 this way, and 1, 2, 3, 4 this way. Now I know these 2 green points have to be on our parabola because it's the same distance, is 4 units away from the directrix and 4 units away from the focus. So by definition, it has to be there. And then I'm going to eyeball the rest. Okay, and I don't know, something like that. Okay, and there's our, maybe I can get a little closer. And maybe I can't. But anyway, there's our parabola. Okay, so in the earlier examples, we started off with an equation and we had to figure out some stuff about it, like the vertex and the focus. Now we're going the other direction. So here we go. Here's example 5. And make sure you see my hint there. It makes things way easier. Here we go. Find the equation of the parabola with vertex this thing and focus that thing. Okay, so I'm going to follow my own advice here, and I'm going to draw a sketch here, okay? So a sketch, it just means it doesn't have to be perfect, but maybe you want to use graph paper. That makes it maybe a little bit easier, maybe a whole lot easier. Let's take a look at 3, -1. Okay, so we got 1, 2, 3, -1. So there's my vertex. I want to put a V here for vertex. That's 3, -1. I got to focus at 3, 2. Okay, 3, 2, 1, 2, 3, 2. Now, the reason that it's important to see the orientation of the vertex and focus is because we want to know if this opens up, down, left, or right, because we got to know if y is squared, if x is squared, if p is positive, if p is negative. Okay. Now, since this is just a sketch and this isn't part of my answer, I'm going to do this. I'm going to say, oh, there's my parabola. Okay. Okay, so it's kind of ugly, but I know that the directrix is going to be down here, okay? Because the vertex is here and the focus is here, I know this thing is opening up. That tells me that x is squared and p is positive. Okay, so let's start with number 1. We know the vertex, okay? This is the vertex right here. So h is 3 and k is -1, okay? So those are 2 things that we need to know for the equation. But we also need to know what 4p is. But before we figure out what 4p is, let's figure out what p is. And that's what this is right here. This is the distance between the vertex and focus. In other words, that is, and it's a distance, so it's really the absolute value of p, okay? And remember, the absolute value of p, that's the distance between the vertex and the focus. So we've got 1, 1, 2, 3. So that is 3. Well, the distance between this, of course, is also 3, okay? All right, so that's what p is. Now, to figure out if p is positive or negative, I know my parabola is opening up, so p is positive. If my parabola was opening down, it'd be negative. So I know p is 3, okay? So the parabola is opening up. Okay, I don't like that. Here we go. Is p positive or negative? And of course, because it's opening up, this is positive. All right, so now we know, boom. Okay, so now we know p is 3. So 4p is 4 times 3, so that's 12. And now we can write the equation in standard form. Remember, it's opening up, so x is squared. So x minus h squared equals 4p, 12, positive 12 because it was opening up. If it was opening down, I'd put negative 12 there. And then in parentheses, y minus k, so y minus -1, we usually put as y plus 1. And there we go. Let's take a look at example 6. In example 6, it says find the equation of the parabola with, now gives us the focus and directrix, but it also asks us to graph. So here we go. Maybe easier to start graphing what you know already. Okay, perfect. Okay, so we got the focus is -2, 3. -2, 3. And to remind ourselves, that's not the vertex, it is the focus. I'm going to put an F there for focus. Okay, directrix at x equals 4. Well, x equals 4 is a line. We know that x equals a constant is a vertical line because it has to cross the x-axis. So x equals 4 is right here. Okay? All right. Maybe easier to start with. No, already. We already did that. We know this parabola opens. Okay, does this open up, down, left, or right? Okay. Well, I know there's the focus, so the vertex has to go smack dab in the middle, right between the focus and the directrix. And there was 6 units there. 1, 2, 3, 4, 5, 6. And so we go 1, 2, 3, and there's the vertex. Okay. And because I know that there's the vertex, there's the focus, there's the directrix, I know then that my parabola opens to the left, okay? Because the orientation of the vertex and the focus, I know it opens left. Go ahead and write left there. Now, P, positive or negative? Go ahead and figure it out and write that down, okay? Positive or negative. All right, so if it opens to the left, I know y is squared, okay? Because if y is squared, it's either opening right or left, but it's opening to the left. So hopefully you put negative right there. Negative. Since the vertex is halfway between the focus and the directrix, the vertex is, that point right there is 1, 3. Okay? P, let's find P. Remember, P is the distance between the vertex and the focus, but it's also the distance between the vertex and the directrix. It's the same distance. It's 3. So P is 3. 4 times 3, 4P is 12. And so now we can write it in standard form. I know that it's opening to the left, so y is squared and p is negative. Hopefully you caught that. Here we go. So we have p is negative 3 because it's opening to the left. Excellent. All right, here we go. So now the equation is, well, the vertex is 1, 3. And remember, y is squared. So it's y minus k squared equals 4p times x minus h. That's how we want to write this. Okay, so y minus k. So k is 3. So we got y minus k, y minus 3, in parentheses squared equals 4 times p. Well, that is negative 12. I know it's negative because it opens to the left. If it was opening to the right, that'd be a positive 12. And then this is x minus 1. The only other thing we have to do now is to graph this. And so let's do that. Let's find our 2 easy points, okay, by using the definition of a parabola. So there's our vertex. That has to be on our parabola. And we're going to find two other points. So the distance between the focus and the directrix is 6. Okay, it's always 2 times p, right? So we go 1, 2, 3, 4, 5, 6 up this way, and 1, 2, 3, 4, 5, 6 that way. And now we have these 2 points. I know this point right here has to be on there because it's 6 units from the directrix, 6 units from the focus. By definition, it has to be on the parabola. Okay? I'll eyeball the rest, and there's our parabola. Okay, so the homework is Parabolas Part 2. Now, if you look at Parabolas Part 2, we have the first 3 are just like Parabolas Part 1, so do some practice there. Okay, and then we have 4, 5, 6, and 7. 5, 6, and 7 are similar to what we just did. So if you need to watch the video again, watch it again. Work hard. Finish Parabolas Part 2 for homework. Email me with any questions. Have a good day. Hang in there.